Good evening to all of you. Are you able to hear? Okay. The analytic education in India, that's a panel discussion. And I have with me luminaries in the field of analytics, experts who have implemented analytics and who have both theory and practice knowledge in depth. So I will allow them to give their views on certain questions we have prepared, and we have exchanged notes with each other so that the delivery is effective. In today's highly competitive environment, organizations must unshackle themselves from routine ways of looking at data, and they have to be innovative and use technology and software to sift insights from complex databases, including big data, and implement those insights for effective decisions. So the art of modeling a problem, finding out the best solution, and successfully implementing the solutions are the hallmarks of business analytics and business intelligence. In this context, what should be the role of analytic education in India? Institutes that offer analytics programs, what should they do to address this? And enormous demand exists for all institutes to float business analytics programs. Technology is the driver, software is the driver, the domain knowledge is the driver. Perhaps the heart of analytics revolves around statistics and operations research as the two eyes of business analytics. In this context, what should be the role of analytic education in India provided by premier institutes? So let me just prepare. I have got some questions, but not necessary that it is read verbatim. But the most important part, perhaps I would ask, I will start with ANSHUMAN, that what should be the ideal curriculum for analytics education in India in terms of theoretical rigor, interwoven with business applications and application orientation. Then the other members can chip in. It's not necessary that each member has to answer only one question. We will make it more effective. So, ANSHUMAN, sure. I begin with you. Yes.
So, can you hear me at the back? So, thank you, sir. So I think I'd just like to, start with thanking the organizers for, giving me this opportunity, to be here with this distinguished panel and to share, some of my thoughts, on this. So I think with regards to, be it analytics or data science, we, within Cognizant, look at three broad, skill areas, right, where we would like to have expertise of each and every analytics professional or data scientist that we either hire or train internally. So the first aspect of it is the IT or the software engineering or the data management piece, right? So data is the raw material for all analytics. So one should be able to query big data or small data or complex data. One should be able to automate that query because the data volumes are large. So writing, be it web scraping through Python or using R to extract data or all of those. So that is one of the pillars I believe of any strong analytics curriculum. So the second component then is the math or the statistics or the algorithms piece, right? So all the way from discriminant analysis to logistic regression to optimization, simulation, and going all the way to some of the high-end algorithmic frameworks like cognitive computing or artificial intelligence, right? So that is the second pivot. And then the third piece, and I think one of the most important piece is around client communication or project management or what has been called storytelling with data, right? Because you could have the best, you could have extracted all of the data, cleansed it really well, gotten to 90% accuracy. But if you're not able to take those results and then put them in a business context and communicate to very senior stakeholders, then you're not then you're essentially underserving what you were sort of asked to do, right? So doing those communications, managing complex projects, especially when data is usually distributed across silos. There are multiple stakeholders, right? There's the IT folks, there are the business folks, right? How do you manage all of those expectations? How do you eventually implement the decisions of your analysis on the ground, and more importantly, track them over time, right? If you run a churn analytics project and you come up with some decisions around how you can manage churn, and then you actually go down and implement those policies. I mean, the results of those policies take time to show up, right? So putting in systems in place that can actually track the ROI, I think is important. So again, just to summarize, so we see the curriculum or the capabilities in three broad buckets, right? So the IT, software, data bucket, the math and the statistics and the algorithmic bucket, and then more of the business communication, storytelling with data, and the project management bucket.
Thank you. Would you like to add, Professor Mukherjee, to ANSHUMAN's point? You have got both academic and industry experience in abundant measure.
Now, I'd like to add one more thing to this, or the two more things I was thinking, because he's very correctly identified technology, he has identified stats, he has identified storytelling. There are one other aspect which we refer to as the business domain knowledge. Okay, without understanding what retail is all about, without understanding what telecom is all about, numbers become a little bit abstract. As we all know, if you take a statistical tool like regression, run it through R and show it on Tableau, it is a garbage in, garbage out. You can put any number and the answer will come out. Now, whether the answer is making sense or not a sense is something which can be addressed only if you have a knowledge of the domain. Okay, so that is one important piece. The other important piece, and which is slightly different, is when we see this sudden rise of analytics training. It takes me back about 15 years, and I'm reminded, Ms. Thiru is here, when SAP first hit the Indian shores, you found ERP training shops sprouting out at each corner, and many of them with pirated SAP software. Okay, and some kind of similar thing is happening today. You find people, oh, we are an analytics shop, analytics training shop. So, and here I find, they just perhaps teach SAS, or they perhaps teach R, and they claim to be analytics. I think we need to make a distinction between a tool and the discipline. And unless we can understand it very well, and that is why I would like to say a holistic approach would make things much nicer.
I just want to add a point before I proceed with the next question. Today, software products are competing for statistical space. So they are creating also an impression that everything about statistics is available in their product. One should not fall into the trap of believing that any software is equivalent to the subject knowledge called statistics. So software packages may be competing, but you should be master of the subject, because no software is equivalent to the subject. Anything would you like to add?
So I think,
Vikas.
my perspective, I'm not a big data expert, so I'm an odd man out in this panel. But I'm involved in analytical education and education per se from a publishing background. So we have a dilemma all the time when we create curriculum with professors, but most of our books and curriculum we create are done by top professors globally. there is a college view to things and there is an industry view to things. So for us, the biggest challenge always is how do you balance it? Academics feel, and we have very big academics on my right, is that theoretical knowledge is most important to engrave into people, and unless they understand that, they cannot become better practitioners. Now that is where this teaching shop story comes in, is that because the gap remains, the teaching shops start to teach these tools and everything and start to fill this gap. So if the colleges at the college level do that along with the demand of the industry in the way you are just describing, I think that challenge will go away. But to do that, it requires world-class curriculum, it requires world-class trainers, it requires a methodology which allows you to do that by scalability, because the challenge in most of these new technologies is the availability of talent to write about and the availability of talent to teach about. So I think unless and until this change has this bridge is not taken care of, it will not be easy to say this or this. There would be Y2K kind of things coming all the time. There was one Y2K, it became a big business for all of them. Now it is data analytics. So how many more years it remains? It's a story, but till the time it is there, yes, there will be hundreds and hundreds of teaching shops like the SAP ones for the next few years.
Thank you. Ankit.
So I principally agree with what ANSHUMAN and other panel members just said. However, I think that it's also a problem of mindset. It's very important to understand that analytics is not a mere technical proficiency but a very core interdisciplinary skill. And besides mere technical knowledge about theoretics and application of a tool, a person should also be very adept in terms of business acumen and storytelling. So there is a big gap between what people think while enrolling about what they really want from a course and what the course is actually tempting them to educate about. Analytics is a very core function of the top management, and it has to marry somewhere with the business objective, that is finally the return. So in terms of analytics, technology is a very core component, but even putting it to a business usage and understanding the impact is very important. And that's where I think that for any analytics related course being taught anywhere, people with some prior work experience actually hold an edge because they're able to relate the impact of the tool better because they have seen scenarios before and they can actually appreciate the utility and the benefit of the tool.
Okay.
I think you have made a very important point around interdisciplinary nature of these things. I think that's another problem at the academic level globally, that within, if you talk about engineering, nowhere in India engineering big data analytics is taught. It's an MBA thing. Let MBA schools teach it. Contrary, in the US, the top analytical schools are institutes of technologies. Why? Because again, they have a different view to it. So the interdisciplinary nature of education which is going to happen. Another good example I can take which will be much more easier to understand. Let's talk about hybrid vehicle design. Now in that you have mechanical engineering, you have electrical engineering, you have software, you have chemical technology because you're talking about hybrid batteries. How do you teach that to somebody in a college? Because the electronics department says you only have these things to learn. The computer science guys will say you have this thing to learn. So if this needs to be upgraded and scaled up, the whole concept of class-based education should go away. You should pick and choose subjects, create credits and pass a degree or a course. I think that is where the education has to go, and analytics could be one of the starting points of it.
Thank you. I just want to go to a next aspect. I am of the opinion that analytics exists with and without big data. Now, how important is big data analytics? How important is big data analytics to business administration today? Is it essential for survival of the company? What are the implications of this to analytics education in India? I will start with Professor Mukherjee on this.
Okay, let me put it this way. all these new tools and technologies do have an impact on business, okay? But it's not that, you know, companies will die without them, okay? Now, I'll give an example. Again, I'll come back to, in the long, 15 years back when the ERP boom had hit the country, okay? And all of us in PwC and everywhere, all other companies were, you know, kind of telling people, all corporates that, you know, ERP is the way to go and you must convert to ERP and this and that and whatnot. I see a similar echo happening today. And when we go to every company and we're saying you need to do analytics. But in 15 years, I think many companies have, you know, established their ERP platforms and everything's in place. All across the world, okay? Everybody has got SAP or Oracle or something out there. Has it had a dramatic change in the whole economy? It has become the hygiene factor, perhaps. I don't know. There are still, we have still the same problem. The problems lie with finding customers, problem finding with finding vendors, problem finding with doing things optimum manner. So the businesses kind of remain the same. You know, while it would be difficult today for a company to work without electricity, it will be difficult for industry to work without petroleum. Similarly is the case with certain IT solutions. Can a company work without a software solution? I don't think so. On the other hand, is any software solution essential? I don't think so either. For example, today we are seeing many new things are appearing. So in a sense, the more things change, the more they remain the same, okay? So I will not say that, you know, without big data, nothing will happen. I mean, we need analytics, we need to run the business. For that, whatever is required, it will be available in some form or other. While it's good to have, certainly, to have an analytics, but I don't think the world will come to an end if Hadoop was eliminated from this planet.
This one distinction is analytics a modern term used, for example. Previously it was called data analysis and all that. So analytics, if you say that I look at data without any preconceived objectives, I look at data and suddenly I discover pattern trends which I could leverage. Is that form of analytics real analytics? Or I look at data with objectives and then do some survey to find out that, and then analyze the data, interpret and give some major findings. Is that analytics? What is the difference?
So
ANSHUMAN.
I think the first approach that you described, right? You start with data and you try and figure out patterns. So I think that is how I differentiate data science and data analytics in my mind, where data analytics is more about having a given problem statement and then going about trying to solve that, right? Figuring out what the data is, what the methodology is, right? Maybe trying out different techniques and then eventually getting to the results that solve that given business problem. And so that to me is analytics. On the other hand, when I start with data and without any preconceived notions, right? I may not even have notions around what data to start with. I should only be looking at customer and operations. And when I start with that open slate and that open frame of mind, I think that starts getting more in the direction of how typical science works, right? How, say, astronomy works, where you're collecting data from all from all these celestial bodies, and then eventually looking at it and then exploring the phenomena that is taking place in this system. So in my mind, I think that is what differentiates data science and analytics. And of course, analytics can start moving into the direction of data science as you say, start looking at that same problem slightly differently, right? So for instance, customer churn is a very traditional business analytics problem. You know, it has been solved for many years in multiple industries. But you know, what happens when you start incorporating non-traditional data sets to predict customer churn, right? So you want to combine it with Twitter feeds, you want to combine it with your Facebook profile, maybe you want to combine it with your geolocation history. Then suddenly that well-studied business problem, which was in the field of analytics, suddenly starts taking on a data science flavor, right? So once these multiple data sets come in, how do I combine these data sets in a meaningful way that will help me, move in the right direction, right? So that's how I see.
And I think you're right, Anshuman, that the whole concept of instant decision making is a change which really is exploding in terms of this area. Is that today I go to Flipkart, okay, you bought this, your friend bought this. So all of this which is happening on a real-time basis and allowing a business decision or a transaction to take place is, I think, is where this thing is merging together, basically.
Just giving a perspective of how the different user organizations are warming to this latest trend of analytics, I would state that most people make a very fundamental error while defining analytics and data science. These are two totally different elephants. Data analytics is just limited to traditional statistical analysis with tools working on traditional structured data sets. Whereas data science goes much beyond it, and it extends the boundaries of traditional analytics to include and marry different data sets that are emerging, be it SMS, be it email, be it free text, and then marry that entire data into one whole, and then using that data through advanced algorithms like machine learning, neural networks, support vector machines to actually enable the company through predictive and prescriptive analytics. And this is where the importance of analytics would really grow in the coming years, because in today's world, for example, I represent e-commerce, and I know how daunting it is for any new company to make a mark or to sustain its operations for not even 10-year duration, but even 5 years. So it's about gaining the competitive edge, knowing what people are buying at competitor stores, how can you service them better, and then extracting them back to your store. So analytics from the prescriptive and predictive standpoint is going to gain traction, but most companies from the user side really don't know how will that be achieved.
Yeah. This is the one small, I would say, smothering point. That is the lack of perception, which you rightly said. Neural network is artificial neural network, you call it, the multi-layer perceptron. If you say it is the heart of data mining, which is part of business analytics, what you find, even neural network uses some logistic function or a Gaussian function or hyperbolic tangent, some of these mathematical and statistical functions it uses, except it is considered a black box because the weights cannot be fully determined, but it's a predictive model. So what happens is, at the core of all these things, including machine learning process, such as your cart classification, regression tree, everything, there is an element of statistics which needs to be mastered for understanding. So that gap we will have to address in the education. Data analysis in the traditional way, and data analytics and data science, all these things should become integral part of business analytics program in the educational system. There is no escape, because if you have a data scientist, and there will be a friction between a data scientist and a business analytic professional, is always going to be there, and this gap should be bridged, I would say, just adding to what you said. In other words, there are 4 pillars in business analytics: description, descriptive analytics, what has happened; diagnostic analytics, diagnosis, why it has happened; predictive analytics, what will happen; prescriptive analytics, what should you do. Within these 4, the entire curriculum, the methodology, everything will have to be interwoven. This is how I moderate, what you said. Yeah.
Yeah, I think, and just to add, I think from a, data science perspective, I think the key word to me, I think, is science, right? So data analytics and data science, data is common, right? So it is the analysis / analytics versus, the science part. So I think having that scientific approach of, starting with a hypothesis, conducting and designing, business experiments that will generate data that would either, make you accept or negate that hypothesis, right? I think is the way to think about it. And of course, the analysis that you could be doing could be as simple as, just dividing two numbers, by each other, versus vis-a-vis, a neural network or a decision tree, right? But the approach that you take, the kind of questions, that you're looking to answer, right, I think is what will eventually, differentiate, both at the face value, as well as the kind of people who will eventually get absorbed and become successful as a data scientist, right? So I am out there building a, quite an aggressive team for data science within Cognizant. And I think these are some of the kinds of things that, we look for in the talent, right? Sure, the technology, the techniques, the tools, environment, and then make, sense and structure out of it, right? What is the path that you would take to eventually, start from this very, diffuse environment and then get to something, meaningful?
If I may add out here, we brought up a brilliant idea of data being common from analytics to science. If you look at science, science at its very core is a method of induction, from going from the specific to the general. Okay, we have heard of, it's true or not, I don't know, that an apple fell on Newton's head. From that, he could extrapolate that to figure out how the sun moves around, or the earth moves around the sun, and so on and so forth, and how the galaxies move. This is perhaps the best example of science in action, when you go from the specific to the general. Similarly, I observe, people sitting with dark suits out here. Can I infer from there that everybody in analytics wears dark suits? Maybe not. But if I could, that would perhaps lead me to a wonderful, hypothesis or premise that, if I find people in dark suits wearing red ties, they are analysts. Now the point is, so we are making a hypothesis, we are moving forward, and then we are predicting. And then if the prediction works out, for example, in the case of Albert Einstein's theory of general relativity, he predicted that there will be the movement of Mercury in a particular manner, or there will be a curvature of light behind a dark star. Now he could, by induction he predicted that, and this was proven, I think, after 10-15 years during an eclipse. So this is the point, the predictive part and the inductive part. Okay, the induction moving forward from the specific to the general, and by this predictive part is what sets apart data science as opposed to analysis of data, which is you have a spreadsheet and you do charts and graphs.
See, why data science is required, one analogy I will give. Why do birds fly? Because they have wings. Suppose you write a regression equation and correlation, you will get an r squared 1. Birds fly because they have wings. Suppose I give you wings, can you fly? You cannot fly. So that part, I think, where to use the model, what are their assumptions, and understanding, I think will have to be a most critical component of education, I feel, based on what all you have said, data science and all. Let me move to another important thing, natural language processing. So I would like to ask any one of you to start this. Do you think the unstructured qualitative data in plenty, which could be big data also, will it be crucial for decision making in the future for and sifting insights from them, what are the challenges, and what is the future outlook for text mining using digital data. If everything is unstructured, which is going to be in plenitude, how do we address this, and is it the future? It may be relevant to you also, Ankit.
Yeah. I think the era of natural language processing and through that the importance of different text mining techniques is only bound to grow. I'll just share a very personal perspective from my work experience. I am working in an e-commerce company, so my company doesn't exist on ground and it's just present online. So even the interaction and different interfaces with customers are purely online. So we really can't float any offline survey the way it used to be traditionally done using AC Nielsen and then employing some consulting firm to arrive at a net promoter score that will tell where my company stacks vis-a-vis competitor on different operational metrics. Now everything is being recorded online at different interfaces. In terms of customer feedback, I get a very good idea about what the customer is feeling about my product and service through the feedback that he leaves on my page. I can even compare that feedback with the one that is being left for my competitor by going to his page. Then there is a whole lot of other things that I can easily derive if I am having the medium to analyze that data. For example, if I can throw a series of different price options for a particular merchandise and gauging the customer behavior on the basis of the price shown, I can even get some impression of the customer's sensitivity to a particular product's price and his reservation price for that product. So what I can really do with all these things is that I can increase my profitability and return on marketing and investment by only showing personalized offers to people at a price. Obviously, this is a very sensitive area, so it has to be in products where variable pricing can be tried to a certain degree. But if that exists and if I'm able to show the customer the price that he's actually willing to pay for that product, I can actually increase my margins accruable on every sale. And this entire thing is only possible through text mining because in today's world, I'm getting data flow in different forms. It can be VoIP, it can be the interactions that my customer care executives are having with customers on phone, through email. It can even be responses that I'm getting through SMS marketing. It can even be the bounce rates or the impressions that I'm getting on any emailer or campaign being shown on Facebook. So all these different data and their sets are very different in nature, and the only way to marry them and make some sense out of those is text mining, according to me.
Like to add any point?
So yeah, I mean, I think text mining, natural language processing, I mean, no-brainers, they will be very important. We as humans, we communicate through language, be it, written or spoken. Structured data is not even, anywhere close to the amount of unstructured text or speech data that we produce. I mean, use cases are, sky is the limit on what kind of use cases, might be built. Just imagine if, all the conversations that we had today in this conference, right, were somehow captured, right, of course, with specific filters around them. And if we could mine them, we could probably figure out, given that all the, the top analytics talent is here, we could, pretty much figure out where we are probably going over the next, 6 months to 1 year, if not further. So, I think, yeah, I mean, it's very interesting how in this domain all these different disciplines are coming together, right? I mean, the people who went to study English language, were in some way, at some point, trying to get away from computing and mathematics. And, now computing and mathematics is in fact following these people, right? And again, if a linguist can pick up some of these tools and technologies, I mean, I think they can make a great career, for themselves, right? Again, going back to some of the original discussions where you need to have a strong understanding of statistics or mathematics or probability right? Similarly, you need to have a strong understanding of language, right? How is it used? What are the different nuances in which we use the same word? How does that impact the meaning and the insights that, or the misinterpretations that could happen? So again, maybe I may not be able to actually get to learn all of that richness of language. But again, I mean, if we pick someone who is trained in language theory and get them, up to speed on the tools and the technologies, I think those kinds of folks would have, exceptional careers, I think, in industry.
The other one is with a standard thing, skills. People develop skills in the software. So the new analytic language R is emerging in a big way. So is it a strong contender for standard package such as the SAS or the SPSS, or will R dominate? Is a question which I would like to put to anybody. Probably will, yeah.
Whatever little knowledge I have from the publishing background is that there will be a coexistence of multiple things at all the time. There will never be a is or R. There will be an R, or there will be a SAS, or some other tool comes in. The coexistence will happen because of specific needs for specific things. So there could be a generic that everybody knows English here is fine, so we can communicate. But then you still have your own dialect, you still have your own language. So I think it will be a coexistence about, it's not about this or this. It's more
Can
about.
we say it may coexist, but can we say the market share or the dominance of this will come down? Let me put the question a little differently. It's not that something will vanish.
Better comes in.
No, I'm asking your perspective.
I think that SAS is clearly the dominant market leader now, but the usage and adoption for R is increasing because of its open source nature. But at the same time, adoption in big MNCs or big corporates is always towards SAS, because things like newer versions in controlled environments, data integrity and security are assured in SAS compared to R, which has an unregulated state. At the same time, because of the expensive nature of SAS, the adoption for R is increasing more in SMEs compared to their bigger peers. So R is steadily increasing its market share. SAS is losing its market share, but I really don't see R superseding SAS in like in coming times at least. But for SAS to really maintain its market position, it has to do something very aggressive and very efficient in the coming times.
Particularly tech, yeah.
No, I'm saying, just to think a little radically, again, I'm just throwing it out there. I mean, who is to stop, SAS from making itself open source, right? I mean, if so many people are making businesses with open source tools, maybe they can come up with a.
They've already started actually.
Okay.
University edition.
Yes.
It's not open source, it's free but not
It's
open
free,
source.
it's not
Yeah,
open
so
source.
some
It's
novels-
muft but not mukt.
But it is free.
So I think, yeah, I mean, I think there could be very, very new business models that could emerge from, from any of these vendors. And with regards to our, at least in my experience, again, most of the production work that we see is still largely in SAS. The R work usually is more of, proof of concepts, of, new things that people want to explore, without putting too much investment into, tools and technologies. Most of these, say, text mining type work will either be in R or Python. Right? So I think Python is a very, very strong contender, given that, most of the web is built on Python. And if you're doing anything, web related, Python itself becomes a very strong option. And then also, I think some of the constraints around support, right? So, I mean, a lot of the companies are looking, I mean, they don't really want to be in this, open source free space with no support, right? So, they are looking for support. And so I think that's where things like, Revolution are, right? Which is now with Microsoft come into the picture. So, I think again, so it's a balance of all these factors. I think SAS it's still dominant. Its usage has gone down, and I think Whether something can be completely sort of eliminated, I don't think so.
That's true.
If I may add something out here, the analogy I would say is mainframes and COBOL. Okay, its legacy. We heard that around 1990 that mainframes will die, COBOL will be gone. Okay, everything will become Java and whatnot. I don't think that has happened. Okay, there are still, particularly Indian outsourcing companies, still support a lot of mainframe work. Now, the point I'm trying to make is, if you already are a mainframe shop or a SaaS shop, you will continue to be in mainframes or in SaaS. But I doubt if anybody starting anything new will start something with mainframes. If you look at the history of the web, despite Linux being free, open source and all that, all the world's web servers are running Linux. I mean, everywhere. You know, the LAMP and the WAMP architecture, basically is all open source. So, so the point is, because internet, e-commerce thing, everything started after the era of mainframes, nobody even thought of, even though there were web servers available on mainframes, very much there, but nobody even thought of going back to mainframes for doing websites. They all went to the new technology. Similarly today, if you already have, for example, I used R when I was SAS when I was doing my PhD. Long ago, 25, 30 years ago, we had mainframe SAS. So there are companies like that who are running SAS on mainframe. It will be very difficult for them to move out. But today, if a new company is starting or a company is starting a new project in analytics, it will be quite likely that they will go with R or Python. I'm not saying R is the only one, but maybe Python is also a very strong contender for that.
Fine. One of the things perhaps I would like to add here in R is what I have noticed, its graphic capabilities. In a single graph, if a person runs a regression, let us say sales is a function of advertising, and I would like to see the regression equation line with scatter plot for 4 regions in India. All the 4 regressions with scatter plot in a single graph with 95% confidence level or whatever you specify can be captured by R. That is the power using ggplot. So it has got some wonderful graphic capabilities. In the modern era, perhaps I agree with Professor Mukherjee that new enterprises, they will perhaps use more of R. That is the reading. It's not that others will not be there. I agree with VIKAS, it's all there. So some of the broad facets we have covered. We said that technology is an important part. Maybe that we should give consideration. Some skills are required for business analytics to be successful. A competitive world, you should equip yourself with tools and techniques. The relevance of big data and the ideal curriculum which one can think of, which will have an industry institution interaction, so that the products produced by these institutes will be marketable product, not a makeable product, and the curriculum must address, and the new analytic language R will dominate, but it cannot eliminate other ones. All of them will coexist, and what is happening is the new company which is starting its business perhaps will go for R. So this is the way, and these things will have to be looked into, including big data in the curriculum. That is the panel discussion overall summary. Now I invite a few questions so that the members can answer, and then we say come to the closure.
But before that, I think we should thank the audience for being around till this evening. I have a couple of thoughts. Maybe some of them have asked their car to come at 5:30. That's why they are still here. Others are part of the event management crew who cannot leave until we leave. For the rest of you, thank you very much for being here, and we have our we are here to answer your questions.
And the way you are concentrating, I am sure you are actively listening to the panel discussion. Thank you. Any question? Welcome. We will answer. The members can answer. Yeah.
SQL is perennial. I mean, SQL is perennial. And I'll give you 2 examples why. Okay. Okay, first let me do a full disclosure. I'm an SQL DBA. Okay, so I have a vested interest in talking about SQL. But there are 2 reasons. When Hadoop, which is the big time big data fellow came in, they did their whole thing in Java. The whole IT community, Java, tough thing. But so they had to come out with Hive, which makes Hadoop look like a SQL server. Bach gaya sab koi. Okay, so lot of effort, a lot of relief all across. Now we have got HQL, which is a very close cousin of SQL, which means that SQL is a very important part of people's lives. Number 2, look at R. You have an R data frame and you can do various kinds of selections and this and that and all kinds of things. Very powerful stuff, no doubt, select this, that, all that. Then there is something called SQLDF. SQLDF is a package which allows you to run SQL, okay, on R data frames. Again, great relief in the IT community, because since SQL is there, life is much easier. So hence I am saying SQL is in our blood. In the IT community, whoever has dealt with data, he has got SQL, under his skin. So I think that SQL will continue to play a very important role wherever you go to, because all the other packages would like to look like SQL from outside. That is my opinion.
Similarly, Excel will be Atma, it will not die, spreadsheet. It will continue to be there. Atma cannot be killed, That's what Lord Krishna says. Nainam chintanti shastrani. So all weapons cannot penetrate, pierce, air cannot lift, fire cannot burn, and water cannot wet. In the place of Atma, you substitute with spreadsheet, Microsoft Excel.
Yeah, I think just to add to that, I think one side of the story is the technology piece, right? As Sir described, that this will always be there to transform, right? And I think the more important question that I would ask if I was in your place, right, is that all I want to do? In the sense that technologies will keep changing, right? It was SQL, it became Hive, it will become SQL data frames. Maybe that is your core interest, right? I mean, then that is what it is, right?
Yeah. SQL is there. Yeah.
Then it is. But I think if you have just been in SQL because of chance or because of whatever the opportunities got presented to you at that particular point of time, I think, and you have some other interests, right? I think I would suggest that some of the other dimensions that we talked about, the rate of change of the technologies. Eventually, I think you will also come to a point where it will be that how many times do I learn a new technology? So just a thought that I thought I would share.
Should we allow the rest of the questions to be taken offline?
Maybe one.
We have a chairperson rushing for a flight, so
Perhaps, yeah.
I think we can take it off.
should we?
Yeah.
Okay, so we'll take it offline.
We'll take it off.
You can always meet our
Maybe one
panelists
question you can ask to satisfy you, then take it offline.
That's a very large question to answer.
No, nothing is the best. We are not saying that. We are only raising a question, what is the future? Because anything can change. Who expected this mobile technology, you can conquer the entire world? 10 years ago, 15 years ago, you not. Now it is rubbing and touching technology. The moment I get into the bus in Great Lakes, everybody starts rubbing and then cross words and everything, whatever they do in the mobile, and everything is done today.
No, no.
No, it's not like that. It's not like that. It gives you certain creativity which you enjoy. Because there may be still people who may not like to code. They would like to have a click point. So,
Yeah, okay, just to add to that, I think
Maybe we'll take it offline.
about workflow.
Maybe take it
So the way typical projects would
to leave,
work
right?
is that you would do the predictive modeling, right? You do it in R or SAS, and then you will deploy the model in SQL, right? You will get the weights of your logistic regression, and then deploy them within SQL queries to actually score, your real data, right? So again, don't tie yourself again to a tool or a technology, right? Try and do as many tools as you can, but make sure you have a sound foundation of, math and statistics, and, the business communication and, those aspects.
even when you are doing text mining, you cannot escape the statistical association principles. This word is associated, there is a confidence level, there is a support level, there is a lift ratio. So some probabilities will come, and that's how they do that. Okay, I think we will take questions offline now. On behalf of the panel and behalf of the organization that has organized this fantastic summit, I profusely thank all of you for your patient listening with attention, and it is really a very inspiring thing for all of us.
Thank you very much.